Good morning, everybody. Thanks for joining us again for the second to last webinar in our series, Building Smart Energy Efficiency Essentials for Modern Homes. And now we're going to talk about modern practices for not so modern homes. How can we apply our skills and experience in HERS ratings for existing buildings? So as always, we're just going to give it a small amount of additional time for other folks to show up, and we will get started then. Okay, that's enough time here. Getting into the absolute home stretch, last two webinars. Looking forward to this here. So today we are going to talk about the elephant in the room here, which is, it's great to talk about all the opportunities with new construction. That's certainly what a lot of our utility partner programs are focused on. And that's a little bit what this series has been about here, is trying to encourage people to look to the opportunities with above code programs to improve homes. As we know, we're on a little bit of a legacy energy code here in this state. It's a energy code that's 10 years old, and frankly speaking, worse than even what the published code was 10 years ago. So suffices to say, there's a lot of opportunity for upping our game in new construction. But then what about renovations? What about existing homes? I live here in the city of Detroit, and boy, you wouldn't believe the amount of renovations going on in the city of Detroit. Yeah, believe the hype. Obviously, not every single home can get that kind of treatment, but a lot are. There's a lot of reinvestment in our core here in the city of Detroit. Are we building back with energy efficiency in mind, or are we just focused on the aesthetics of the building? Well, it depends on who you're talking to. So that's why we're here to encourage people to understand how you can apply these principles, the same stuff we've been talking about, largely speaking, with new construction, and how can we apply it to existing homes. Thanks again to DTE and Consumers for sponsoring this, and looking forward to showing why this is so needed, especially here in the state of Michigan. I myself am from the state of Michigan, Chris McTaggart, president of Building Efficiency Resources. I have been your main companion and instructor throughout this series of webinars over the past several months. I live in the city of Detroit. Our company has HERS raters all over the state of Michigan. And so we really know a lot about Michigan and care about the state of Michigan. So this is why we're invested to come and bring our skills and knowledge to really talk about the application of modern building practices to promote energy efficiency within Michigan's building stock. Okay. So existing homes, who cares whether or not we got old homes in the state of Michigan? Why does that matter? Well, because as time went on, building codes have gotten better, and they've started to require more over time in terms of efficiency measures. So a house built today, even though it's a 10-year-old code, frankly speaking, that is still pretty good in comparison to the average vintage here in Michigan, which is frankly speaking, pretty old at this point, pre-1980s. Why? Well, because Michigan had its heyday back in the turn of the 20th century. We were a big state in terms of the industrial economy, and we made a lot of stuff. And so people could come here and live and make a good living here in the state of Michigan in the 20th century. Still the case today, but the boom times really were the early 20th century. And as a result, our housing stock reflects that in a lot of ways. So you got to realize that energy codes started out in 1975 in this country with ASHRAE 9075. That was the first energy code. And it did discuss the application of energy efficiency in residential buildings, although even then, energy codes per se did not really become a thing that really were codified into law for residences really until the 1980s. And, the 90s with the Energy Policy Act of 1992 ended up really promoting model energy codes across the country. And if you don't know about that term, model energy code means a bunch of smart folks got into a room and debated about how to build an energy efficient home. And then they created a book, and that's called a model energy code. Now, you can, as a state or municipality, choose to adopt that model energy code, or you can choose to take it and amend it. And you could amend it to make it more stringent, meaning harder, or more energy savings expected. Take the state of New York, for example. They're about to adopt a version of the energy code that's similar to the 2024 IECC, but they've made some actual strengthening amendments to their state code that are even more stringent than the 2024 IECC. That compares to Michigan, that took the 2015 IECC and, frankly speaking, amended it down to the point where it performs closer to the 2009 IECC. So, there in the 1980s and 90s, it was actually called the MEC, the Model Energy Code, and there were three different groups that promoted energy codes. Ultimately, they all kind of combined their resources to become the ICC, the International Code Council. And in 1998, the first IECC was released. And for all intents and purposes, since 2003, it's been on a 3-year development cycle. And so, again, we're here in the state of Michigan, we're kind of somewhere right there in the middle, if you see that. If you take a look at the generations of codes, if you will, you've got the stuff from the 70s, 80s, and 90s, and then you got the stuff from the early 2000s. We're still kind of in that early 2000s level of expectation. It's not a bad thing. 2009 IECC had a lot of good stuff that it brought to the table, like blower door testing, duct leakage testing, etc. But nevertheless, here it is. There's 2024 IECC. It is an option. We will see where things go in the state of Michigan in the future with codes. All this being said, Michigan's housing stock, our buildings, largely predate the advent of energy codes on average. You can say, well, wait a second, I live in a brand new subdivision that just got finished. Well, yeah, that's built to an energy code, and everything here over the last, say, 3 or 4 decades has been subject to an energy code of some degree. But really, a lot of our housing is quite a bit older. How do you know that, Chris? Well, because there's people who have actually researched this stuff. So, in terms of owner-occupied housing, Michigan is, the median U.S. is 40 years old. 1985. Median Michigan is more like 45 to 50. So again, saying that ASHRAE 9075, it's not like every single state and municipality in America picked it up as soon as it was printed, and it really wasn't a residential focused code anyways. Really, our average home, our median, that is, home, has not was not built to an energy code, and that's just the reality. And those who have lived in Michigan your whole life, this to be true because I grew up in Michigan and lived here most of my life, and our buildings are what have pretty high energy bills in general. I mean, a lot of us. Again, I don't want to generalize. I live in Metro Detroit. It's an older part of the state, but the buildings also aren't that comfortable either, and that's just the reality of living in old buildings. And here's the deal: it can the median age depends not just on the whole state, but it depends on hyper local regions here. So, like, if we take a look at Southeast Michigan, and again, if you're in the center of the state or the west part or north part of the state, you'll have to apologize, or excuse me for focusing on Southeast Michigan. But we are the highest population concentration center in the state. So, if we take a look at this, we see, the average housing stock in Detroit is probably something like 1945, something like that. That's the average in most areas of the city of Detroit. And then you get into the immediate ring suburbs, and you've got, maybe the 50s or 60s, something like that. And then, progressively, obviously, you can see where it starts filling out other places. You get more into the hinterlands, the exurbs of Metro Detroit, and all of a sudden that vintage shifts to being somewhat newer housing. So if you're over in Fowlerville, you're like, well, wait a second, our houses aren't that old. Yeah, there's a couple old farmhouses, but really most new homes they're relatively newer. They're built in the 80s or the 90s or the 2000s or whatever. Yeah, but that's the exception here. Michigan does have new construction. We have had new construction for ongoing, but in general, our housing stock vintage is older. And who cares about that? Well, it just so turns out that the older the homes are, the more energy intensive they are. And energy intensity is sort of a different way of describing inefficiency, or rather efficiency. And there's more to the story here than just efficiency, because if you take a look at this national chart, this comes from ResStock, which is an NREL platform. It sort of simulates every building in America based off of sort of assumed values, based off of geographic research and things like that. So you'll note that the most energy intensive states tend to be the coldest ones when you look at this chart. And so, we look at Michigan is amongst its peers, amongst the highest intensity. Minnesota is number one, sort of shadowing the fact that they have a lot of older housing stock, and it's even colder. And actually, I take that back. North Dakota is number one. So arguably the coldest of one of the coldest of the states. So it's not that surprising that some of these upper Midwestern, upper Plain state, some of the Rocky Mountain region states are amongst the most energy intensive. But then, Michigan, here it is. We are one of those states as well. And so if you compare that to, say, New England, where it's just as cold in places like Vermont and New Hampshire and Maine, but their intensity is a little bit less. And so to me, that tells you something about the realities of what we're dealing with here in Michigan. We're dealing with the fact that we have an older, inefficient housing stock. So anyways, I think I've proved my point there. So looking at the HERS index, and how can we think about this from a HERS mindset? Well, let's take a look at this chart here. You know, a typical older home, we're going to put an asterisk next to it, is maybe 130 to 150 on the index score. Frankly speaking, I'd say that, you know, that 130 probably reflects more that median national average. So like something from the 1980s. That might, you know, be better reflected as a 130. But for us in the state of Michigan, you know, maybe we're a little bit older even than that national median. So maybe we're closer to maybe 140 or 150 on average. But I'll tell you what, when I bought my house, I was pretty close. This was 8 years ago. This house was pretty close to 200 on the HERS index. And you're like, well, how is that possible? Well, because I had leaky ducts, an 80% furnace, an old gas tank water heater, 15 ACH 50, original wood windows with storms on most of them, but still older windows that were not well performing. 19 maybe 2000 era appliances, a mix of efficient and inefficient lighting, and not a stitch of insulation in the whole place. That's what I was dealing with when I bought this 1920s era home. And guess what? It just so happens to be that Detroit is full of these homes. We got tons of homes that looked just like mine. And most people probably either don't have the means or the wherewithal to buy these homes and to start to, you know, make them more efficient. I did it because I wanted a comfortable home in addition to an energy efficient home with stable bills. So I'm glad that I've made the enhancements into energy efficiency in my home. But regardless, you know, at this point, you know, I'm definitely sub 100, probably not quite where I wish I could be, but I'll get there. I need to replace my water heater and maybe do a little bit of additional air sealing and then get a good ERV, and I'll pretty much be good to go. The HERS reference home was built to essentially the worst piece of stuff that you could build in 2006. That's basically what the HERS reference home is. It's basically minimum prescriptive insulation levels plus minimum efficiency appliances and mechanical systems of that era, plus a lot of sort of other bad practices, a leaky home and ducts that leak and, you know, things like that. So that's what a HERS 100 is. So think about this, you know, think about a lot of those houses built in kind of, you know, our newer homes in Michigan. A lot of those are probably similar to that. You know, they're not terrible, but they're not great necessarily. If you get to where we're at with our current Michigan code, if you were to simulate this on the performance level, it comes out probably somewhere in the 70s to 80s as sort of like a worst case. Now, obviously, we have homes that are performing better than that to the modern Michigan energy code, but we're just talking about like worst case scenario. That's about what it would come out as. For Energy Star version 3, you're somewhere in the mid 50s to 60s. You get into these better versions of Energy Star and ZERH, and you start getting into the 40s and 50s, and you know, you can get to FIAS, and you can be in the 30s or 40s, and then obviously we can go all the way to net zero. So this is sort of, you know, the chart of what's possible. So again, talking about, well, how do we get there? How do we apply that to, say, an existing building? Well, you can kind of sort of do what I did. The first thing that I did for my 1920s era Detroit home was I focused on my building enclosure. I dense packed my above grade walls. I insulated my attic, and I insulated my foundation walls and my rim joists, and performed air sealing in order to substantially drop my air leakage in my home. Why did I do all of that first? Well, because I wanted to conserve first. That way I can figure out when I do fix my heating system. I wanted to figure out, well, what size did I really need for heating and cooling. Um, so that was first and foremost. I didn't do it all the way with the building envelope and conservation. I didn't go all the way to brand new windows. It took me 8 years to get to the point of putting in new windows, but I finally have new windows. I'm very glad to have new windows here. Um, then we can get to efficiency measures. And, again, I kind of mixed some of these. I got good lighting and appliances pretty much right out of the gate, even before I ended up doing building envelope stuff. Well, why? Well, because we needed new appliances. And like I said, I did my furnace and new AC, got a 95% efficient furnace and a 15 SEER AC. I got that, pretty soon, and fixed my ductwork before I did new windows, for example. My last thing I got to do is I got to replace my water heater because I still have my old tank natural vented water heater, but we'll get there. Eventually, man, I would love to add renewables onto my house in order to get closer to zero. The problem is I live in a neighborhood with a lot of large, old, mature trees that shade my property and my roof. So I may or may not get to that point. We shall see. So here's some ways to approach, whether regardless of my home and how I did it. Let's just say you're working with a customer or you're working on your own home. How can you go about considering making upgrades? Well, you could use the HERS index. That's a way to do it. Now, the HERS index is not, number one, it's fuel neutral. So say you're wanting to switch fuels, it's not necessarily going to tell you the actual impact to your bills just based off the HERS index. Just understand that. It's also a comparison to a theoretical reference home. So there are certain things that may impact the HERS score more than what they actually impact the energy bills. So I would take a pretty close look at the energy bills. I would take a look at heating and cooling load reduction because the energy bills, that's what people are actually paying. And I'd say we're all more concerned about what we're paying today because we're paying more for everything. So there's more of a case to be made for energy efficiency in terms of energy savings and dollar savings than I think there has been for quite some time. But this reduction in heating and cooling load, you can think about that as sort of a surrogate for improved comfort. Because let's take a step back here. Let's just say I ignored the building envelope and put in just brand new appliances, lighting, HVAC, and a water heater. So I went for all good, efficient stuff. Well, my bills would have gone down, but I wouldn't be any more comfortable. Right now, I'd be adjacent to, it's cold outside right now. It's in the 40s or maybe even the 30s, and I'm right near a couple of exterior walls, and those walls are relatively comfortable because I dense packed them full of insulation, and my windows are new and high performance Energy Star windows, and so right now, mean radiant temperature in my house is good. I am not feeling drafts in particular right at the moment. And so, keep that in mind, that reduction in heating and cooling loads can also be a good surrogate for looking at comfort improvements. You probably want to think about costs. Obviously, it depends on the customers. Some customers, they don't really care. They want the comfort, they want the modernization of their homes, and they believe in energy efficiency for either philosophical or environmental reasons. So some consumers who may be renovating their homes, they may not necessarily care if it's exactly going to pay for itself. They may just think it's the right thing to do, or they may have other motivations. But I think it's still, for most people, they're going to want to understand what their ROI is. And then finally, how do we, scale these upgrades? What order of operations do we do? All right, let's take a look at a typical Michigan home. Here's the baseline. So here's a typical home. Again, we're saying that this sucker is built in 1978. That's the average home, I guess we're saying, right? So it's leaky. Probably. Now, and you haven't done enough existing home audits and things like that. You have to be careful about broad generalizations about air tightness. you can have really leaky new homes, brand new today. It's less common, but it can happen if people say have tongue and groove ceilings, and so they just don't have a really clear air barrier and things like that. You can have pretty leaky homes, or somebody has a big giant chase running to an attic that the code officials missed, and the builders missed. You could still have very leaky homes today. Meanwhile, you could have homes built in the 1960s that are actually pretty tight. They have a tight, flat ceiling. They don't have ducts running into the attic, and so there's minimal penetrations. They tended to not have a gaudy amount of can lights and things like that in the 1960s. So I've actually been into some of these sort of mid-century homes that are tighter than you would think they would be. A lot of air tightness in existing homes too. It depends on things like the configuration of the home, in particular, the configuration of the top floor. Again, not to overly generalize, but homes that have a flat ceiling, in my experience, tend to be tighter than homes that have vaulted or cantilevered ceilings, or like story and a half style, spaces, such as my home. I have a 2.5 story home. My top floor is a partially finished and partially unfinished attic space. That made it a lot more difficult to air seal. And honestly, I still didn't probably get it as good as I wish that I would have, frankly speaking, due to some less educated contractors who did the work, unfortunately. But we'll get there one of these days. But think about like a bungalow, or a Cape Cod style house, a 1.5 story house, having those attic knee walls, and then you've got a top that is sort of unaccessible, that has a flat ceiling. Oftentimes those are very tricky to get right. And so anyways, we're making up a theoretical home, and we're saying it's about 7/8 H50, because if we averaged them all together, that's probably about right. So that typical home from the late 70s, early 80s, probably has some attic insulation. We're going to say an R20, so maybe R19 baths or something like that up there. Probably not perfect. Exterior walls R11 2x4s. That was still very common in that era. Our windows, we're just going to assume a old double pane window. So an older double pane window basically here. Foundation walls, 0. Why? Well, how many of y'all's basements are insulated here in Michigan? Probably not most. Because why is that? Because we have old homes, and we didn't have an energy code. And even here in recent years, say the last decade or 2 decades, when we have had more modern energy codes, a lot of sophisticated builders have turned to using performance methodologies that have allowed them to trade off foundation wall insulation, for better, well, for worse, in my opinion, for worse. I will say it makes a huge difference having insulated basement walls. Don't let anybody ever tell you anything different. In the wintertime, if you are trying to use your basement at all, man, it is so great to have insulated basement walls. I'm all about it. I would encourage it for everybody. I would discourage anybody from skimping on it, because I think it's awesome. I like using my basement, and I like to use it year round. Slab, well, it's a below grade slab. Typically that's uninsulated even in new construction. No ventilation, not surprising. Heating system, we're going for an 80% jobber. Why? Well, because that was common back in the 1970s and 80s. We didn't really have condensing furnaces. And the thing is, once you're locked into a certain venting condition, then it's a premium to upgrade to a condensing furnace. So that's why you see people continue to change out 80s with 80s. It's just so much easier, if you're an installing contractor, to just, hey, this one died, I'm just going to go ahead and put another 80 in, because I can vent it the same way. I don't have to think about venting the fresh air intake, and then the combustion gases, as you might need with a 90% unit. So that's why we end up seeing a lot of kind of same old stuff going in. Now that's going to change. Supposedly in 2028, 80% furnaces are going to be gone. And so probably sometime by 2030, I would imagine we'll have exhausted our 80% furnaces, in warehouses, and they'll be pretty much condensing units from here on out, or heat pumps. Um, Air conditioning, 10 SEER, something that was like, 90s or early 2000s vintage. Ducts, we're just assuming that most ducts are inside conditioned space, but you have some in an attic with, minimum insulation on those ducts in the attic, and we're assuming that they're kind of leaky. Why? Well, my experience is that Michigan ducts are pretty leaky. I hate to say that, but they are. We don't have as fastidious of contractors when it comes to using mastic or tape or sealing the boot to drywall connection. We use a lot of panned return systems, so we kind of have leakier ducts. For the water here, it's an older atmospheric unit. Lighting, they've upgraded some of it. Some of it's fluorescent, but they haven't gone all the way to upgrading the LEDs yet. And then we have kind of 2000s vintage appliances. So the HERS reference home appliances, that was sort of the worst thing you could get in the year 2006. That's what we've assumed for this typical Michigan home. This is the average go and buy a resale and what you might see. And again, it's going to depend. If you're buying it in the city of Detroit or Kalamazoo or Lansing or Pontiac or Grand Rapids, you may have homes that have no insulation, just like mine. You may have homes that have single pane wood windows, that are worse than these windows. So, this is a hypothetical scenario, but it gives us, I think, pretty close for argument here. All right, so here's how the bills break down. So this is sort of, early 80s, home here. We've got a lot of energy going to heat, not surprising. We've got a lot of energy going to lights and appliances, and a little bit going to cooling and water heating. You may go, wow, that's surprising. I would have figured there was more going to cooling, but we don't have big cooling loads. We just don't. Now, a lot of this depends on occupancy. To be honest, this comes from sort of how the HERS procedures look at a lot of this stuff. So like the thermostat is set to 78 degrees within the HERS procedures. Yeah, I know a lot of other people who are running it down to 70 degrees for cooling. So, it really depends on the user. So take that with a grain of salt. But I think that the point here is that 50% of your costs are going to heating. And that's pretty true. And our index score is about a 130. Look at that, just about what we were sort of riffing on, that probably the average home from the 1980s would be about that. For our heating load, we've got 80,000 BTUs per hour. So probably the home has 100,000 BTU or maybe even 120,000 BTU per hour, 80% furnace. A big old sucker that makes a lot of noise every time it turns on. And then for cooling, yeah, they probably have a 3-ton, maybe even a 4-ton system installed. So that's, $3,800 annually. That's over $300 a month. That's pretty expensive if from my perspective. I think paying $300 a month for energy bills in the scheme of everything else I think that's kind of expensive. I wouldn't want to be shelling that out every single month on average. So we're in the inefficient category. And so we modeled it up to prove what the res stock data shows. We have an inefficient building stock here in Michigan. All right, so what happens if we just wanted to upgrade to minimal performance here with the Michigan 2015 Energy Code? Well, and we did it performance. So performance-wise, we're tightening to 4.5 ACH 50. So we took care of most of the obvious stuff in terms of air tightness, upgraded that attic to, a little bit over an R38, exterior walls in R13, and then the U factor on the windows went to basically a code window, a 0.32, 0.3 window. And then we put R10 on the basement walls, either maybe with foam board or with the cellulose board that's out there and a fair amount of people use in Michigan, maybe with the diaper, the vinyl faced fiberglass blanket product. I wouldn't recommend that, but you could. Ventilation, we went for an exhaust only ventilation setup on a timer. Heating system, 90% furnace, 13 SEER AC, nothing gaudy necessarily with equipment. We left the duct configuration the way it is, but upgraded the insulation to R8, and then dropped our duct leakage substantially as well. Upgraded our water heater to like a minimal performance power vent unit, and we updated to 75% efficient lighting. Kept the appliances the way they were. All right, so here's how it goes. We dropped our energy bill by about $1,000, pretty close, and about $900 per year. And all of a sudden now, heating costs have gone down. It's only about a third of the pie instead of about 50% of the pie. Cooling remained the same. Water heating went up a little bit just because of the pie shrinking overall. Lights and appliances become a bigger end use because, again, we didn't upgrade the appliances. So here it is. We get to the 80s on the HERS Index score. We dropped our heating load down a decent amount, about close to 30% savings or so on our heating load, and about 30% savings on our cooling load. That's pretty good, honestly, for having improved our insulation and air tightness in our building. So, when we go to replace these systems, we could right size them with probably more like a 60,000 BTU per hour furnace and a 2-ton cooling system. All right, so Michigan's performance code, it's an improvement. It's a little bit behind the times. 80s on the HERS Index. When I got into this industry, and Energy Star version 2 was king. That was in the the late 2000s, and so and then you had to get an 85 on the HERS Index. And that was Energy Star version 2. So this is essentially like hitting Energy Star version 2. And you may say, well, that's good. It's an Energy Star home. No, it's not. Energy Star has been on version 3 and now 3.1, 3.2, and 3.3 since 2012. So, again, 10 to getting close to 15 years behind the times in terms of minimal acceptable compliance here. Again, it's pretty much like a 2009 IECC home is sort of Michigan Performance Code minimum compliance. So what could we do from a retrofit plan? So again, this wasn't necessarily saying the retrofit plan. This was just sort of showing you a baseline Michigan performance code home. So for our retrofit case, here's what we're going to do. We're going to improve air tightness, attic insulation, leave the exterior walls, leave the existing windows, upgrade the foundation walls, put in ventilation, put in a good furnace here, and a good air conditioner. Nothing crazy and superlative, but we're going to make improvements. We're going to seal the ducts really, really well down to sort of Energy Star levels, improve the duct insulation to R6, and then we're going to put in a tankless gas water heater, LED lighting, and Energy Star appliances. Our HERS score goes to a 76. So here we go. We didn't mess with the exterior walls. We left those. Why? Well, because they're encapsulated in drywall. You'd have to take out all the drywall. Maybe you want to do that, but probably not. We left the windows too. Why? Well, because you could make a pretty big impact on efficiency without messing with windows. So we kind of went for the things that were possible to get to. And made those choices. So we got to a HERS score of 76, better than the Michigan Performance Code. And we dropped our heating and cooling loads down substantially, and our energy bill goes down to being less than that of the performance home as well. Again, we chose to leave the existing windows, though, for that case scenario. Now we're going to look at it as what happens if we upgraded the windows here. So under this scenario, by leaving everything else the same, except we upgraded our window package, we also are assuming that we got some air tightness out of that. Why? Well, because newer windows tend to be more airtight, and we can take more care in installing them. A home built in the 1980s probably did not have spray foam or caulk around the rough opening of those windows. So there's a good chance that those windows, not only do the window themselves leak, but also the rough opening probably leaks a fair amount. So when we improve windows, we should assume that we get a decent amount of air tightness improvement as well. So doing that, now we're in the 60s on the index, and we've dropped our bills a little bit more, an extra couple $100 per year. Well, keep that in mind, folks. I mean, I installed new windows this year, and I did so knowing full well that for the amount of money I was going to spend on them, the ROI was never going to happen there in multiple lifetimes. I mean, we better hope that the nanobots come and start cleaning our blood here so that I live to be 200, because otherwise these windows are never going to pay for themselves. For me, I did it for comfort. That was the primary reason, and function. My old windows were covered in lead paint, and they were drafty, and they had poor radiation control on them, and sound came in, and so and I couldn't really open and close them easily. So my wife and I decided to upgrade our windows because we wanted new windows. We wanted everything that came with new windows. Energy savings, frankly speaking, is just a bonus. And I hate to say that, but I mean that. It's just a bonus. Note that the windows that we put in were Energy Star certified windows for a cold climate. If you have, you may say, well, that U factor doesn't seem that great. Yes, but with Energy Star windows, if you have a higher SHGC in a colder climate, that will still qualify you. So again, going back to our presentation from, wow, it was probably back in June at this point, but we talked a lot about windows, and the reality is a higher solar heat gain coefficient in Michigan can be a good thing because we're not a big air conditioning state. And so, you can see that here. We actually, see that the cooling load went up a little bit because we went to a higher SHGC package, but, our heating load went down. And it went down because less heat loss off the windows, more solar heat gain in the winter time, plus less infiltration. So I'm an advocate for replacing windows. Just keep in mind, they're not going to pay for themselves more than likely, not anytime soon. It's going to take a long time. If this is $200 a year that you're saving on windows, and let's just say you're the average home and the cost to update your windows is $15,000, that's going to take a long time in order to pay back. $2,400 per year, $15,000, 7-8 years, and that's not accounting for other things like had you invested the money or inflation, etc. Look, I don't care. Again, there's benefits to replacing windows, but it's just you're not going to get a ton of savings out of it. So so this shows the existing windows, 76 on the HERS index, 53 heating load, 20 on the cooling load, $2,700 annually. Here we go. We made an improvement here to upgraded windows, and it saved a little bit of money, saved primarily on heating costs. So and just note the whole pie continues to shrink here, basically because our total energy consumption goes down. So, okay, well, let's take a look at an example about what about gas versus electric? Obviously a lot of people are focused on heat pumps in modern day. What happens if we did a heat pump instead of a furnace? Isn't that better? Well, it depends. I wouldn't say that heat pumps are better or worse necessarily. Obviously, there's the benefit if you have a heat pump, which is electricity based heating, that if you have the ability to put solar or another form of on site renewable energy on your home, you might be able to offset some of your heating energy use and therefore cost with on-site power production. You can't do that with gas. And hopefully we think that, over time, Michigan's energy grid is going to get a lot cleaner. And so over time, that heat pump should have less emissions associated with it over time. I think that's a moving target right now, especially with big data centers and things like that, sucking up a lot of electricity. It's hard to say where we're going to get all that capacity from. And so I'm not personally convinced that a heat pump necessarily makes a home more environmentally sound. Well, how does it look in terms of costs? All right, so here's two examples. That same upgraded window condition. We left the walls the way they were. Again, same condition. But here's the deal: we're upgrading our furnace on one side on the left, and our water heater to get high performance gas systems on the left, and then on the right we're upgrading it to high performance heat pump for space heating and heat pump water heater on the right. Note that the HERS index score goes up. Okay, well, you may say, well, I don't care about the HERS index score. Again, Chris, you kind of said it's a little bit like a game. Yeah, again, the HERS score has value, but it does depend on what you're comparing. When you do an electric home, you're comparing it to another electric home. If you're doing a gas home, you're comparing it to another gas home. So it's hard to exactly always get apples to apples, comparison on the score. But here's the deal: look at that cost difference. Our annual energy bill goes up to $4,400 per year in the electric case versus $2,500 per year in the gas case. So where did that come from? Where's the energy? Well, it's the heat. Air source heat pumps are good systems, but they're not perfect systems. They are sensitive to outdoor temperature conditions that reduce the efficiency at very cold temperatures. And Michigan has some pretty cold temperatures. So by going all electric, our heat bills our energy bills are actually more than where we started from. So again, this is 4,400 for electric, 2,500 for gas. And if we go all the way back to the original case here, this was our base case, $3,800. So again, I'm not discouraging anybody from getting a heat pump, and this is an energy model. It's not necessarily the perfect God's truth, but the reality of the situation is that, just going all electric, it may save carbon emissions, but it's not going to save your pocketbook in Michigan because we have pretty expensive electricity in Michigan. So I'm not discouraging anyone from going all electric, but you got to keep that in mind. Okay, so let's think about other things. Weapons, if we did, let's rip out, I don't feel good renovating this home and leaving the drywall as it is. Weapons if I have, moisture issues or mold behind the drywall. So we're just going to do a gut renovation, and we're going to compare if we spray foam those walls full of foam, high density spray foam, versus leaving the existing bat in and then doing continuous insulation. So meaning that we go ahead and we pull the siding off the home and we put in 2 inches of foam board and then reside. So under both of these scenarios, we're saying that the air tightness got a little bit better. Again, it will drop by another 1 ACH 50. And why is that? Well, because by either spraying the wall cavities full of foam or taking off the siding and putting in continuous insulation on the exterior with, we're just going to say, with taped seams, then we're able to get more air tightness in addition to better thermal performance. And you may be looking at this and saying, how can I get R16 in a spray foam application? That's the homogeneous R value. Actually, you can actually get up to close to an R23 cavity by upgrading a 2x4 to fully filled high density spray foam. That's totally possible to do. So how does this change things? Her score drops a little bit more. Bills come down a couple hundred more bucks with the removing the drywall and doing the interior spray foam job. Whereas with the removing the siding and leaving the existing bats but putting on continuous insulation, our HERS score drops even more, and we drop down to $2,200 per year. So now, instead of it being over $300 per year, now you're all the way down to less than $200 per month. So this is, again, the high density foam system. Heating costs are at 30%, versus exterior wall cavity, you're at 28%. The heating load is about the same, but you can see the benefit of the continuous insulation. It improves the overall thermal performance of the exterior walls by putting on that 2 inches of foam, because our heat design goes down. So take a look at this. We've gone all the way from 80,000 BTUs per hour as our design heating load, all the way down to 34. We've reduced heating demand by substantial amount. We've reduced it by more than 50% by taking all these measures. So taking a look at this chart, if you go all the way to this exterior walls cavity plus continuous, now you're in that Energy Star version 3.2, 3.3 realm. That's a high performance house. Good job, everybody. I mean, that's great that we were able to accomplish that. So it just kind of goes to show that working with a HERS rater who's competent about existing buildings and running through some scenarios can really help homeowners understand better the options that they have. Now, obviously, you might say, cynically, am I ever going to get that money back by doing all these upgrade measures? And what I would tell you is do what I did. You don't have to do them all at once. I didn't do literally the entire high performance renovation to my house immediately. Now, you can if you've got the money and resources and the time and the vision and the contractors and everything like that. In some ways, I probably could have just did it. I probably should have just did the whole thing all at once, but I was running a business and I wanted to do some of the work myself, and I just didn't have time to do it all. So I kind of took it in pieces. I dense packed the walls. Why? I didn't have any insulation in my exterior walls. I wanted the comfort benefit. I insulated my attic. Why? Well, because it had no insulation. I wanted the comfort and I wanted the energy savings. I also did air sealing. I insulated the foundation walls. Why? Well, because I wanted the comfort and I also wanted the savings. I spray foamed my rim joists. Why? Well, because I wanted the comfort. I wanted the energy savings. I don't want a drafty home. It's not fun having a drafty home. Nothing cool about it. The appliances came faster, lighting came faster just because we wanted the fit and finish of the home to be improved, so that came faster. My mechanical system was somewhere in between. We held on there for a little bit, frankly speaking, because we could, because we made those envelope improvements first. And now we just recently did windows. It took me 8 years to do windows because, frankly speaking, it's a big cost, and I just didn't have the time or the money, or I wasn't ready for it yet. Now I was, and I made the decision to go to that point. My next thing is to go and get an upgraded water heater, and we'll have to see what's out there. Do I go for a tankless gas high performance unit, or do I go for a heat pump water heater? I still haven't made up my mind. No, we're going to see. Am I ever going to update my exterior walls to add continuous insulation? No, I will not, because I have brick facade on my home, and that's not going to happen. And a lot of houses in Michigan do, and so sometimes you just got to live with what you got, and we got to make the improvements that we can. We're not going to have, I mean, I could have ripped out all my drywall and done double stud walls on the inside, and I could have really gone crazy with my exterior walls. I didn't. Who knows? Maybe some point in the future I will. But for now, I'm happy with what I got. It's possible to leverage this system, the HERS system, and energy modeling to make sense of how to take on a big renovation project like this. And I highly recommend it. So, all right, folks, that's it. We've got one last session next week on frequently asked questions. If you have a question about anything that we discussed this entire series, please feel free to reach out and we'll try to get it on the presentation for next week. Otherwise, we'll look forward to seeing you then right before Thanksgiving. Y'all have a good rest of your day. We'll talk to you then.